K. Prakash, working as an assistant professor in the Department of Mechanical Engineering, SNS College of Technology. So in the previous videos we have discussed about the basics of IC engines, components, and then we have discussed about the 2-stroke engine, 4-stroke engine, and working of an IC engine. Today we are going to discuss about the performance test in an IC engine. So in the previous video we came to know that what is IC engine. It is an internal combustion engines. So based on the fuel, it can be classified as petrol engine and diesel engines. So for today's explanation we are having a twin cylinder diesel engine, and then some setups is available. I will tell you what is it. So before going to this, so if you link with this with design thinking, we are linking the concept with the design thinking. So if we go for the design thinking, the initial is, the first stage is empathy. So what is empathy? So in the IC engines, the energy is converted from one form to another. That is, the heat energy is converted to mechanical energy. So the chemical energy available in the fuel. So how much energy is converted into this heat energy? So based on the heat energy, it is converted into mechanical energy. So now we are conducting a performance test to increase the output, to find out what is the output given by this engine. So by knowing this, we can enhance the engines, or we can find out the various parameters involved in this, so that we can on the parameters to get the more output or to increase the efficiency. So before going to the topic, let us see what is the setup available in this IC engine and to conduct a performance test. So if you take this color, it is in a green color. So this is an engine you have already seen, and if you take the second part, here it is a load setup is available. So this is called as dynamometer, where a dynamometer, here it is an electrical type dynamometer. We have already seen that we are having a mechanical type dynamometer, hydraulic dynamometer, and here it is an electrical type. And then the inlet of air is taken from the atmosphere. So to have a constant supply of air to store, we are having an air tank here, and it is connected with the inlet. And there is an exhaust pipe where the burnt out gases goes outside. And then if you take here, the fuel is from the tank. So here the fuel comes from the diesel tank, and here there is an fuel pipette available where it can be controlled, and then the temperatures can be measured here, and then there is a manometer to have the difference in level to find out the pressures. So coming to the performance test, so what we are doing, what we are finding here. So what is a performance test? So in a performance test, so initially we are running an engine and we are calculating what are the powers available, and we are varying the load conditions by this electrical type dynamometer. So before going to the performance test, we will see what are the outputs here we are measuring. So initially what happens is, when the engine is running, fuel is supplied, so chemical energy is in the fuel. So when the fuel is entering in the combustion engines, so it is burnt. So after burning, what happens, enormous amount of heat energy is produced, so that it makes the piston to move. So what happens is, then the heat energy is converted into mechanical energy. So here, so the power obtained in the top of the piston or inside the combustion chamber is called as indicated power. So this indicated power is acting on the top surface of the piston. So next what happens is, so it makes the piston to move downwards. So when the piston is inside a cylinder, when there is a movement inside the cylinder, what happens is, generally a friction power takes place. There is some loss of energy in friction. So next what happens is, so the piston is directly connected with the crankshaft. So what happens is, when the heat energy is converted, the piston moves with the help of the connecting rod. the crankshaft is rotated where the mechanical energy is obtained. So here the energy obtained or the power obtained in the connecting shaft is called as brake power. So initially we are having indicated power, some energy power is lost, that is frictional power, and the remaining we are getting it as the brake power. So if you have a linkage with these three powers, so indicated power is always is equal to the frictional power plus brake power. So here in this performance test, we are going to find out what is the indicated power, what is the frictional power, and what is the brake power. So by calculating this, we can find out what is the efficiency, mechanical efficiency of an IC engine, internal combustion engine. So here initially what happens is, so we are doing a test to compare with different types of loads. So to vary the load, what happens is an electrical type dynamometer is attached. So when varying the load, what happens to the fuel consumption? That we have to make it. So the fuel consumption can be measured here in this setup. So and then what is the pressure? So here we are having we are measuring the H1 and H2 level, and then we can make the calculations. So now what happens is, first initially we are finding the brake power. So what is the formula for brake power is 2 pi Nt by 60, where N is the speed and T is the torque. So here when the engine is running, what happens is the speed can be calculated with in RPM at the back end, okay, by using a tachometer. Whereas if you take the torque is nothing but load into radius. So here is it's an electrical type, so the input power is taken here as V into I. Okay, so the power is here is taken as V into I. So by varying these loads, what happens is the fuel consumption is calculated, and initially the total fuel consumption TFC is calculated with the help of these data. So after calculating the total fuel consumptions, we are finding the brake power. Okay. So we are finding the total fuel consumption, and then we are finding the brake power, and then we are making the brake power, and then TFC values, we are finding the frictional power in a graph. That method is called as a Wilson's graph method. So by same procedure, we are varying the load. We can vary the load here. By varying the load, the same total fuel consumption and what is the frictional power is calculated for each and every load setup. So the load can be varied, maybe on 25% of load or 50% or 75%. The load can be varied, and then the total fuel consumption and the mechanical efficiency can be found. So after that, finally we can have a conclusion that, so for the varying load conditions and based on the fuel, how much fuel is consumed and what is the output. So this can be measured in the performance test. So this is about the performance test. Thank you.